paleontologist believes we could ever get enough ancient DNA to clone a dinosaur, but could fragments of genetic material be extracted from this new tissue?
I think anything is possible. If there are blood vessels and red blood cells preserved in a dinosaur, I think it's quite possible that there will be DNA there as well.
Even without DNA, proteins from soft tissue could begin to answer real mysteries about dinosaur biology. Evidence of warm blood versus cold blood, whether the large body size of dinosaurs is linked to large cell size. The Rogers have a theory that dinosaur mass deaths in Madagascar might have been caused by water poisoned by algae. This poisoning event wouldn't show up in hard bone, but they might be able to test the theory with dinosaur blood cells.
The structure, I mean, there's a lot of structure there.
Yeah.
If there's anything in this tissue that Mary finds that actually can trace a toxin, that would be fantastic. Things like disease, diets, things like that from soft tissues that you can't extract from hard tissue, from true fossil bone.
The hope is that the Madagascar fossils will allow Mary to find more dinosaur tissue. So Ray and Christy gather fragments of their best preserved fossils. A few days later, the samples arrive at Schweitzer's lab at North Carolina State University. She uses the same technique that yielded soft tissue in the T-Rex bone, soaking the fragments in a mild acid that dissolves away the mineral part of the bone. But will she be able to find the same internal structures in Ray and Christy's fossils?
There's only so much you can know from looking at the outsides of bones, but when there's soft stuff inside, the possibilities become almost endless. This is a single cell.
Right. Through photos from her microscope, Mary hits the jackpot. Pieces of biological history.
Now see, this is really cool. It's what looks like vessels to me, connected together, transparent. And you can see right there, you can see the branch points and stuff.
The Rogers are seeing inside their collection of fossil bone as they've never seen it before. Structures that appear to be the vessels that once carried blood inside a dinosaur's body.
This is hooked together. There's a transparent region.
It's a tube with stuff inside of it.
Branching, hollow, organic material that scientists thought could never be preserved in a dinosaur fossil.
That's amazing. But this is from 65, 70 million-year-old bone.
It's too early for these structures to reveal details like dinosaurs dying from poisoned water. But dinosaur soft tissue opens a door that no scientist thought even existed until Schweitzer's work changed that assumption.
There's little doubt in my mind that what she has discovered are internal structures in dinosaur bone. And we may look back and say, well, this sort of approach to looking at fossil vertebrate biology has revolutionized the field. But we won't know that for some time yet.
To get in there and to find soft tissues, to find blood vessels, to find cells, it is an opportunity to go to places that we never thought we would be venturing just 10 years ago.